why to choose GIS as a technology, covering marketing side of things. Again, thank you Electricity and Tri-State for having us. I'm excited to be here, and I hope we can do this every other year. Okay. So, a table of contents. I'm going to do a small introduction on GIS and AIS, comparing both technologies. Then I'm going to go into time considerations as to what to look for when designing a substation, particularly more for GIS. And then sustainability, which is a growing topic in today's industry, which we do have our Econic portfolio, fully SF6 free, and the whole high voltage portfolio from GIS, dead zone breakers, and lifetime breakers, and so on. So, introduction. So before I start, a GIS is a substation. Right? GIS is compact. It's a substation that has every single component that a substation would typically have. You have the circuit breaker, the voltage transformer, the fast acting earthing switch, disconnecting switches, CTs, BTs, and bus bars. So instead of having it in a big field, you have it in a building, or outdoors, or under a canopy. The beauty of this technology is that it's fully modular, and I haven't come by a situation where I had to say that we can do certain things. So a bit of advantages and disadvantages of technologies. AIS, of course, we all know that AIS is the cheapest solution. It's very commonly used. Engineers are very normalized at using these technologies. Labor unions are used to working with these technologies, and it's easy to replace when anything happens. That's because it's in a big field. And some disadvantages, in most cases, will be the large footprints. It has a very expensive operation and maintenance cost throughout its life cycle. Regular maintenance is required because it's outdoors. If there's a hurricane, if there's a sandstorm, snowstorm, or anything, or even an earthquake, you still have to make sure that the substation's okay. And then outages happen every 3 years. Okay. Just a quick raise of hands: who works with utilities or for utilities? And how many people have been part of storm duty? All right. So the good thing about GIS is that it's indoors, right? It's protected, right? So when working in storm duty, the first focus is not going to be to look for the GIS. It's going to be more on the power lines, right? The biggest threat for the electrical industry would be trees, would be falling objects, would be high winds. All right. Now for GIS advantages, the overall cost of ownership is one of the advantages. However, when you're looking at the capex initial investment for GIS, it's going to be at its highest. When you're comparing both solutions, the GIS is a full solution rather than when you're looking at the AIS. Typically, you're looking at the dead zone breaker, which is relatively cheaper than a GIS. Right? A GIS, you're reserving and lowering your cost preparation costs. You have less operation maintenance during the whole life cycle, and it has enhanced security, not only for the GIS but also for the substation, which is a growing topic nowadays as well. Some disadvantages is, of course, the capital expenditure of the technology. The technology is new to a lot of utilities in the West Coast, in the East Coast, Northeast, Southeast, wherever there's a large plot of land. Most utilities haven't heard of what a GIS is. And some disadvantages: the gas handling required during maintenance and repair. That doesn't necessarily mean that you have to de-energize or remove the gas every single time you do maintenance, but maintenance does happen every couple of years. Quick representation of a substation. So substation, we all know that GIS is very compact. It's not as big as a air insulator substation. Typically, I've gotten requests where it says we need to extend an air insulator substation, but there's no space on site, whether it's a power plant or a generation site. They come looking for GIS, and GIS typically fits on site, right? So here I put a quick little example. Let's see if I can get this to work. AIS, typically 48 meters from side to side, and the GIS, you're looking at 5.5 meters for an entire substation. Recently I did a substation building design where a 230 kV was able to fit in 270 by 38 feet. Right? If that were to be an AIS substation, I can tell you that it's going to be 80 times the size. Some benefits: so the GIS, everything sets it together, everything goes together, right? you're doing the factory acceptance test, you're doing the factory acceptance test of the GIS, the full GIS itself. And also nowadays with supply chain being a big issue, the GIS is shipped fully together. That way you don't have to worry about surgery wrestlers coming to site, CTs being coming early. No, in the GIS everything is a simple unit. With this scenario, you're also looking at pre-factory testing of single products in the complete system, and then you're also looking at reduced on-site installation and commissioning timeline. So instead of having to wait for every single equipment to arrive at the same time or at different delivery times, in the GIS you're expecting everything to arrive at the same time. Questions? Planning considerations, number 2. So total cost of ownership. So GIS is very expensive. It's an expensive product upfront, right? But what we realize is that the GIS is cheaper to maintain and operate in the long run. The GIS is meant to last up to 50 years. So when you're looking at the initial investment cost, that cost is starting to balance out. Failure cost from the utility side, they look at that calculated on the basis of cost of power delivery through interruption. So if anything were to happen on the AIS side, how much would that cost to maintain and bring back to service? And then on the operation maintenance side, since an AIS has to be much more maintained, that will also increase the price. Substation performance, you're looking at security, flexibility, reliability, and safety of operations, and the environmental impact. You're having the environmental impact, the air pollution, appearance, aesthetics, and audible noise, including the EMF. So in the conclusion, GIS benefits are more than just on space, but also on price during the full life cycle of the equipment. Benefits, the environmental impact, the life cycle cost, no environmental considerations, advanced features including digital substations, high quality and safety standards, low space requirements, compact and modular, and reduced installation and commissioning times. Why is the industry trending towards substation solutions? We've had hurricanes in the past where it's destroyed substations. We've had earthquakes destroy substations. We've had a bunch of things affecting the electrical grid. And lately, the industry's been working more towards a GIS solution to avoid destruction, right? Severe storms, wetlands, destructive seismic events, malicious attacks. We've seen those a lot in California, we've seen those a lot in the Central Coast. People here in the US have guns, and a lot of the times substations become an aiming field. So when you have a GIS, when it's inside a building, it mitigates that risk. And also high and low temperatures. High and low temperatures inside buildings not really affect. Pushing, you have a bus going outside the building. Typically, that bus is ready to meet the environmental conditions of the area. Seismic, because the GIS has a very low center of gravity, the GIS is ready for the high seismic conditions. And really, the GIS would be weather independence, protects against attacks, and no bullets. And then new construction, it's always easy to plan ahead without having the need to de-energize a substation. If we're going to extend the GIS substation, that's done during the engineering phase of the current scope, and then later on in the next 10 years, if that substation were to be increased, certain things we have a buffer gas compartment that we put in between to avoid it from being de-energized when it does happen. Power outages are disruptive to public and economic life. I think this would most likely apply for data centers nowadays. Data centers lose a lot of money when the substation is de-energized or when the data center is not running, right? So reliability and availability would be the main concern for data centers in the ongoing trend. And any disruption will be critical to the grid. Seismic events. So you see the map. We have Greater Ring of Fire in the west coast, and we also have the Madrid seismic in the middle region. Surprisingly, we also have a GIS in Alaska. We have IGA, which is an integrated GIS solution. And in 2019, there was an earthquake. It was 7.8 7.3, 7.4, and the feedback was that nothing happens with it. Okay. The GIS can also be combined with digital substations, allowing for more resilience. The substation can withstand higher winds, higher seismic events, and flooding if the GIS is in an elevated building. Digital substations, we monitor the gas density, gas humidity, circuit breakers, and partial discharge. All of this is compliant with IEC 68150, meaning that if anything were to happen on site, you'll be able to monitor it from your headquarters. Right? We do have a gas monitoring system in which it's connected through online, through the internet, and you can see what's going on in the substation, if there's any leaks, if there's anything happening. Really. The GIS can also be put in a building. I've seen this a lot in Florida, Louisiana, and more flood-prone regions. Typically, what happens here is that you have the cable and units on the bottom, and you have cable coming out from the bottom. Okay. It can withstand from -55 to +55, which is very prone here in Denver. I'm assuming you can see that. Also in Arizona, we get to see this a lot, or in very deserted regions. Pollution class will be up its highest, and humidity can be reached up to 100%, and you can be safeguarded that the GIS is going to last in here for up to 50 years. Because you have a building, it's completely robust against environmental conditions. It's not affected by water, salt, sand, or dirt. No lightning strikes. In fact, the lightning hits the building, but the GIS is completely covered. And the elevator building will help against flooding. And when we're talking about lead times and building design, then all of that is taken into consideration that way throughout the design, engineering, manufacturing of the substation. As soon as the building is ready, the GIS already arrives to site, or the foundation, really. Physical threats in substations are real. The park is very important to society, and any terrorist attack would be prone when you have AIS substations. So the GIS does have that added level of security, that extra shielding of security when you keep it inside a building. It's not as prone to bullets, and it's not as prone to any type of malicious attacks. Next. Substation security. This is also very important to keep your substation secured. I visited a customer in the West Coast, and their security was tight. They have cameras, they have guards, they have police on call, they have everything on call. Right? This substation right here, substation on the left side and on the right side, you can barely know you don't know it's a substation. And right now we're doing a substation in the Northeast where it's 120 feet on the ground. It's going to be under a park, and I think that's very cool. The interior of a GIS building is all organized, it's cleaned, and then this right here is an example of a substation in the Washington, D.C. area, right in our nation's capital. Substations could be invisible when you're comparing to AIS and GIS. Here you have one example. Before it was an AIS substation, when they did the upgrade, they realized that the substation didn't fit, so they went ahead with the GIS footprint. And I've read articles of this exact substation, and I've seen that house prices around that area have increased. So that's one benefit that it carries. The GIS can also be underground. I wouldn't see why that would be an issue. Nothing's exposed. There's no exposed wiring in a GIS building. When you're talking about the grounding of a GIS, it's typically underneath the foundation, and there's grounding points that connect the GIS to ground. That way, people can safely touch it, and nothing's gonna happen. Any questions? And lastly, very important for safety. Safety is our license to operate, so in the long run, we're also thinking about the safety of the people who are going to work at the substation. GIS is safe to touch during operation. Typically, when you're looking at a 230, 345, 550 kV GIS building, the substation has catwalks, it has stairs, it has ladders. And it's safe to walk around. There's viewports around the substation where you can see if the disconnecting switch is actually open or closed, and you can do maintenance operations with the GIS being energized. Right? Depending on what type of operation maintenance you want to do on the GIS, it's always good to keep cautious of your operation and safety manual. And of course, the GIS fully weather independent, so whether it's raining outside, there's a hurricane, there's a snowstorm, you can always go inside a substation without that affecting it. And then timelines, one of the biggest concerns now is timelines. How do we deliver as soon as possible, especially now where data centers are, critical lead time items, and substation equipment is becoming a huge concern. With AIS, the whole thing with slot reservations, with capacity reservations, with lead times, with how can we manage to energize a substation in 20 months, right? In a GIS, its lead times are approximately 50% of AIS components, and you get the whole substation to arrive at the same time. And then with the ISC schedule, there's a sequence during installation and commissioning. So whether it's a customer steam coming to the substation or it's also going to a substation installed in a synchronous manner, whether there's partial energization happening for a very critical site on site, whether utility or segment, or it's a full installation commissioning schedule where we can energize towards the end. And then the price, GIS and AIS. AIS is relatively cheaper than GIS, but when you're looking at the permitting costs, building costs, site preparation costs, it ends up being approximately a 20% difference. And then throughout the years, once the GIS has been energized, you start seeing that the operation and maintenance cost of the AIS becomes much higher and higher, depending, of course, of where the substation is going to be. For a GIS, it's relatively the same. For a GIS, you're looking at operation and maintenance activities of approximately 8 to 10 years, or 10 to 15 years, depending whether it's indoors or outdoors. For a GIS, it's typically 3 to 5 to even 8 years of major operation and maintenance activities. And fast deployment. So at Hitachi, we do offer two different types of solutions to better support the delivery times. We have skid solutions and we have IGAs. Skid solutions, if the building is not ready, we deliver everything to a warehouse off-site. We assemble as much as possible. We do all the pre-installation off-site. And then the integrated GIS solution is a GIS inside a box. So this brings your auxiliary components, your skids, your standard GIS, and any secondary equipment inside the box. And this factory will be located in Italy. And the same way in the box, that's the same way it's going to arrive on site. So here I have a representation. So the IGA will be the box, the housing, auxiliary equipment, you have the skids, the standard GIS. It's the same GIS as you would typically install in a regular substation, and the control, protection, communication equipment. So the site requirements are 3 simple steps: the civil foundation, the direct placement in the ground or the soil, or it can also come in a mobile substation. Right? So the civil foundations will be the biggest part of the customer's scope, and that will be to coordinate the placement of the IGA on site with the foundations. Also comes with, it can also come as a temporary installation, or it can also come in a mobile installation. So mobile substations, if a substation is not ready to be energized yet, because there's some delays of certain parts or whatever the case may be, the mobile substation can actually work or serve as a coupler in that case to allow for energization, on-time energization, and avoid any delays. The skid solution, so there's 5 quick easy steps. Apart from delivering the GIS to site, to the warehouse, we assemble everything off-site at a warehouse that includes GIS, LCCs, and doing pre-work off-site, so installation, pre-commissioning activities off-site. We then lift on a truck, and this is all done digitally, and then the same steps that were done digitally, they're then translated in real life, right? From lifting and sliding the skid inside the building, slide the skid inside the GIS building, and then directly energize it. And this, if the substation is not ready, then this really shortens the time of any type of installation activities on site. Pre-assembly, pre-commissioning, pre-gas work. everything is done beforehand. So anything that has to happen on site already has happened at the warehouse. This presents lower risk in execution, and if there were to be any type of, let's say, errors during the commissioning side, or there's a missing piece or anything that happens during the commissioning phase or installation phase, is the best time for it to happen, because this can easily be mitigated. Okay, and it's not going to delay the energization dates. Questions so far on the IGA skid solution?
I had a question real quick. So where is it manufactured?
The GIS is manufactured in a Swiss factory, and then the IGA will be manufactured in Italy. Yes.
What type of size in terms of KV and MVA is the capability?
So from 69 kV and up to 420 kV, right? But the higher you go, it doesn't become as feasible. So typically, I would recommend to keep between 69 kV up to 230 kV.
Okay. And size like an MVA?
Right. This doesn't come with transformers.
I think your question's like, what's the max current rating? Is that what you're asking?
Yeah.
Oh, the current rating would be on the 69 kV, you're looking up to 4,000 amps. On the 170 kV, up to 4,000 amps. On 230 kV, on the 230 kV, you're looking at a short circuit of up to 80 kA, but you're also looking at voltage of up to 4,000 to 5,000 amps. Right, so it's the same GIS from the Swiss factory, the same GIS as being assembled at a typical substation on site. Only difference is that instead of going directly to the substation, it's going to taking a pit stop at the Italy factory for full assembly. But the ratings of the IGA and the GIS would be identical.
So, I don't know much about, we don't have any of this at our utility. So, I assume the breakers in there are higher pressures and they're separated from the gas insulated, the trunk, what do you call it? So what pressure do you guys run at? What's a typical pressure system that you guys run at, the whole gas installation?
I mean, during the transportation phase between the factory to site,
In service.
in service, I can answer that after this.
Okay.
Okay. And then an IGA can be either SF6 or SF6. So for now that we're going to this trend of what's sustainable, how can we reach this carbon-free grid, right? So we know that SF6 is one of the most important gases in the industry. However, it is the best gas to use for our circuit breakers. The gas has great arc quenching capabilities. It's the best gas to use in our circuit breakers, but the only fault in this gas is the global warming potential. So this line right here demonstrates the SF6 in our environment, and because SF6 is in our environment for up to 3,200 years, this line's never going to decrease. This line in our lifetime, or the next one, or the one after, it's never going to pivot down. Right? So it's only going to keep going up. Right? And one of the goals that we have at Hitachi, one of the goals that should be put out there, is that we don't want to change anything in our grid. We don't want to have to change capacitor banks, transformers, or switch anything, right? And our goal is to be able to put a GIS and be able to easily replace it with an SF6, keeping the same level of safety and reliability, keeping the same switching performance and parameters. So everything that we have already available in the SF6 products, our goal is to keep the same exact technology and put it SF6 free without the SF6. We can also fit the same GIS in the same footprint of the same substation. So if we have an extension if GIS building is being extended, and it's already SF6, it could be SF6 free because it's going to easily connect with the other one. And of course, you have that pressure differential in between, but you can easily connect both technologies together. And then lastly, operation and maintenance, especially for a maintenance crew in the field. It's the same exact processing tools. As a matter of fact, there's service spare parts that you can take from the SF6 and use it on the SF6 free technology. So nothing changes. Using the same cameras, the same monitoring systems, the same partial discharge, and the same maintenance practices. So the most important thing to know is that the economic technology is still a gas circuit breaker. Nothing changes. Right? We want to keep everything the same and be able to change that one thing that is very bad for the environment, which is the SF6. It's developed and is readily available from 69 kV all the way to 550 kV, and we've also realized that we've been able to scale up the technology to even 800 kV to meet today's market of 800 kV trends, as well as the sustainability trends in the US. Though this technology also has the lowest carbon footprint in the life cycle compared to the market, the carbon footprint of this technology, the savings of the carbon footprint is going to be in the size of the equipment. We don't have to increase the size, and the size is going to be relatively same to the SF6. So nothing's going to change there. And then lastly, with the F-gas, so C4FN is considered PFAS, but it's not forever gas. Right? It's a gas that's going to be in our environment for up to 30 years. And then after the 30 years, it's going to be evenly dispersed into our atmosphere. It doesn't mix with any biomaterial, doesn't mix with water, doesn't mix with plants, doesn't mix with soil, it doesn't mix with anything. It just stands there. 30 years go by and it dissolves. Okay? And our eco-efficient gas mixture is going to be 86.5% CO2, 10% O2, and 3.5% C4FN. So because this is a very highly dissolved mixture of C4FN, it's non-toxic. It's not considered toxic, it's not considered carcinogenic, it's relatively safe. The CO2, the point of the CO2 is to be able to extinguish the arc. The point of the O2 is going to be able to mitigate any toxic byproducts formed during the arc, such as CO. If you have O2 inside the mixture and you have CO2, and it's going to dissolve the byproducts that are formed inside the GIS, and the 3.5% C4FN is only there to be able to give it a dielectric booster to the gas, and also allow it to not increase the size of the technology and maintain the technology the same size as the SF6. Questions?
I have a question.
Yes.
What happens if you have a sudden gas leak? You shut down the substation, or how does?
The same way that it works in an SF6, the same way it works in our Econic technology. It really depends on what kind of gas leak you're having on site, but really it is just refilling and topping it off. Yes.
Are there voltage limitations to this new technology?
No voltage. So as of now, I will show in the next slide, but as of now we've developed 69 kV up to 145 kV, and we've also developed 345 kV up to 63 to even up to 80 kV, which is in our roadmap, and we've seen major success. We've also been able to develop 550 kV, which is available in the market, and it's been already in execution with great success. And we've also been able to prove that this technology is scalable to even up to 800 kV. So given the latest stress with ERCOT, with PJM, that they're all looking into upgrading and doing a 765 kV grid, our 800 kV portfolio will be ready by. It's in the next slide. Okay. Yes.
A great presentation so far, and hope I'm not beating to the punch, but with this C4FN, could you go to an existing SF6 substation, degas, and gas with the C4FN?
So It really depends on the product that you're, on the component that you're trying to, do that, right? So we do have retrofitting solutions, mainly on the GIB. If you have an existing SF6 substation, you want to remove the SF6, you can do it on the GIB, right? The GIB, and all you have to do is change some minor things, the gaskets, the density monitors, and then the absorbers. Right, but on the active part, no, right, the, Econic circuit breaker has a slightly thicker, enclosure, and that is to compensate the higher pressures.
Are the units for this product bigger than the SF6 product, like for dead tank or GIS?
Sorry, can you repeat that?
Are the equipment, is the equipment sizing, I guess you mentioned that it's a bigger tank on the Econic product for either dead tank or, GIS, but is the equipment larger than what you would see in the SF6 equipment?
It's slightly larger, it's slightly larger, but it's not more than a foot, right? It also really depends on which technology you're looking at, right? Yeah, I'll be.
So on the SF6 side of things, we usually look at purity and moisture, so what about this? Are you still looking at the purity of those molecules that line up, making sure that's still holding up with continuous duties of what's supposed to be doing insulating and deactivating?
Yes, so we have done tests on the life of the gas through normal arcs, regularly arc and heavily arcs. And then when it comes to different scenarios like gas monitoring or humidity or pressure monitoring, that gas is a homogeneous gas, right? So the way the gas handling works is that before the substation is energized, the gas is mixed into a homogeneous gas, and that's the same way it's filled, right? So it's not that you're taking the purity of each gas independently, you're taking the purity of the gas itself. And the goal of the product is to be able to make the gas last as long as the equipment or even more inside the GIS. And it will be the same gas handling practices as an SF6 towards an SF6 versus the Econic, the same gas handling practices. Only difference is that you're having a different gas, but the BP will be the same.
I guess what about reporting? Is there any kind of regulations that require monitoring of how much of the C4FN you have?
So if I'm correct, most of the goal right now is to remove SF6 from the grid, right? Whether reporting, this gas mixture, I am not familiar with it, but I think that would depend on a state-by-state basis.
Also, how about the price point of the Econic versus SF6?
So our goal is to be able to have this Econic product into the market and be able to replace the SF6 technology on the market. So when it comes to price, we can discuss about it after this meeting, but I'm sure that we can talk more. And then I think earlier today someone mentioned warranty about the 8 years. We can also do warranty. Okay, spare parts we have, and then if you already have a GIS with spare parts, there's most of the equipment, most of these spare parts are also compatible with the Econic technology. Right. Question? So when you're looking at the life cycle of the GIS technology, you're comparing three things. So Hitachi did use vacuum at some point back in the day when it was ABB, but they switched to Econic because vacuum, this type of technology would be more relative to medium and low voltage gases. But looking at the SF6, you're cutting away the CO2 equivalent by 99.9%, right, which is mainly on the gas. On the Econic, you're seeing a little increase because of that extra material, but when you're looking at the air or vacuum technology, you are looking at a higher material cost, transportation cost, because it is a heavier material. And then lastly, for our roadmap, we have developed a portfolio of Econic circuit breakers ranging from Niton breakers, Datsun breakers, our past technology even, which is our hybrid solution, our GIS, gas insulated line, and then we also do retrofitting for GIO, gas insulated line. So far for the GIS, we've been able to reach 145 kV, 40K, 4020 kV, 63K, 550 kV, 63K, as well as 420 kV, 80K, which is readily available in today's market. In the future, we are looking to release by next year the 245 kV, 63K, 145 kV, 63K by 2027, and the 170 kV, 50K by 2028. For the Datsun breaker, one thing to notice that for transmission partners such as 230 kV, 345, 550, or even 765, the GIS and the Datsun breaker are the same interrupter, so these parts are interchangeable. So if we have already an installed base of Datsun breakers out in the market, and the GIS will be the same interrupter. Questions?
For a GIS solution, is there a lead time delta between an SF6 product and the Econic gas that you had mentioned earlier? I know on the dead tank circuit breakers, it's like 105 weeks for the Econic product, or it's 160 plus for SF6 dead tank. So do you see the same delta on GIS solutions, or does it remain the same as the GIS lead time?
The lead time for GIS will be approximately, it's a 20% delta right now between SF6 and SF6.